I'm happy to talk today about C++ 20 and in particular about the hidden pearls inside C++. Because you know, C++ is a big C++ standard. Okay, this is all what we have regarding C++ 20. We have the big four and we have core library and additional core library and concurrency features. You see, core language features such as three-way comparison operator, designated initialization, consteval and constinit, templates or lambda improvements. On the library side, we have also nice but maybe not so known features such as span, container improvement, arithmetic utilities, a big extension of the Chrono library, which we have since C++ 11, regarding calendar and time zones, and a formatting library. But this is not all. We have improved atomics, semaphores, simple coordination mechanisms such as latches and barriers. We can cooperatively interrupt something which runs, and this is mainly due to this new or improved thread G-thread. Okay, to make it short, I will not talk about the big four. You see, I already did it and you may know them, but you may not know them here, the small pearls or the hidden pearls. So let's start because I have a lot to explain about the core language. First of all, we have a three-way comparison operator. And when you look carefully, it looks like a spaceship, and therefore it's also called a spaceship operator. What does it mean? The compiler can auto-generate the three-way comparison operator for you, and this means that you will get all 6 comparison operators for free. And as I mentioned, it's called a spaceship operator, and you can request it by just saying equal default. Of course, you can also implement it, but anyway. The comparison operator created by the compiler, you need for this the header compare, and this comparison operator is Constexpr and no except. Constexpr means it could run at compile time. I will come to this keyword in a few minutes. And essentially, when this auto-generate comparison operator does its jobs, it performs lexicographically comparison. This means all members and all members are compared in the so-called declaration order in the same holds for all base classes from left to right. And here you may see an issue, a performance issue, but this is not an issue in C++. When you think about comparing 2 strings and you want to decide are these strings equal or not, you will not make a lexicographical comparison. Sorry for this difficult to pronounce word. You will not do it lexicographically. You will do it just by comparing their size. And if the size is equal, you compare the character until you could make your decision. So it is for equal and non-equal. There's a shortcut which makes this comparison faster. Okay, how does it work? When you invoke a smaller than b, the compiler maps it to a, you see spaceship b, and this is the comparison which is actually performed. What is great about this comparison operator is the following. When a smaller than b does not work, the compiler implicitly compares b with a, which is great. Okay. When you already have comparison operator, one of the 6, you know, smaller, bigger, and so on. When you already have one of these 6 comparison operator in your class, they have higher priority than the one auto-generated by the compiler. Okay, this was the theory. As I mentioned it, it's way too much stuff to explain you all the theory. I want to show you something. Have a look here. Here I have a small wrapper around int. You see, my int has an int inside. I have a default constructor. I have constructor. And here's the interesting part. Here I require or say to the compiler, please auto-generate me the three-way comparison operator. I just saying default. And here I did it by myself in line 8. Why? I want to compare instances of my ints with ints, you see? And this is what I did. I just use under the hood the three-way comparison operator. And let me show you how it works. Now I have here a function template is less than, in which I want to compare to variables. I can do it with 2 instances of my int. I can do it with 2 instances of int. Of course, this is trivial, but I can also do it with an instance of my int and an instance of int. Why? Because I implemented the comparison operator for int. And here's the proof that it is done at compile time. You see, I want to have the result at compile time. Therefore, I enforce it by saying Constexpr. Okay, let's continue. I have a lot of stuff to explain. Here we are. I was a bit irritated. Okay, what we also have in C++20 is designated initialization. What does it mean? First of all, it's based on aggregate initialization. Okay, what is an aggregate? An aggregate is, to make it short, a C array or a class type, class structure union, which has only public members and no user-defined constructor. And the nice feature about aggregate initialization is that you can initialize an aggregate with an initialization list. This means you don't have to implement a constructor. And of course, the order of arguments must match the declaration order of the members in this aggregate. And with C++20, this feature becomes even more powerful. Have a look. I have here extremely simple data type. It's an aggregate having values x and y. Now I can initialize it using their name. This looks extremely convenient. The members here can also have a default value, in which case they will get the default value when you don't provide an initializer here. If the initializer is missing, the default value is used. Okay. Narrowing conversion is detected. This means when you want to initialize this int with maybe a double or a float, you will get essentially a warning, but most compiler will handle this as an error. Okay, let me show it to you, this feature. You see, I have a point here. X has no inits, is not initialized. Y and Z have default are initialized in the class. Here I have a point which just displays these 3 types. You see, X, Y, Z. And now I initialize it in various ways. Here I specify each value. Here I specify nothing, and this essentially means that X has an arbitrary value. In my case here, X is 0. Anyway, there's no guarantee. Additionally, I can only specify, let's look here, X and Z. Therefore, Y gets the value 1. And this looks quite nice. Here I only initialize X, and Y and Z get their value inside the class. And only to make it sure, maybe you know it from Python, you have to use the declaration order here. You see, when you first use Z and then Y, Z and then Y, this is an error. Okay. I'm a little bit irritated because I cannot observe the chat window, but anyway, I will go back and look in the chat window later. Maybe you have questions. Okay, now I come to consteval and constinit. What is consteval and constinit? First of all, consteval generates an immediate function. What does that mean? You know presumably Constexpr. Constexpr is a function which could run at compile time. It depends on the context or what you want to do with this function. If you use it in a constant expression, then it runs at compile time. But if the context is not Constexpr, a Constexpr function can run, could run at runtime. Okay, but this is the difference. A consteval function can only run at compile time, and a different term for it is immediate function. And we have a new keyword regarding const, which is called consteval. What does consteval mean? Consteval mean that this variable is initialized at compile time. But here's the extremely interesting point. It's initialized at compile time. Sorry, I made a mistake. I was a little bit irritated. Let's go back. I talk about consteval and I skipped in my head to constinit. Let's go back. Consteval, okay, cannot be applied to the structures or functions that allocate, deallocate, has the same requirements such as a Constexpr function, and is implicit inline. Let's have a look here. This is consteval. This means this function can only run at compile time. Therefore, this is fine. But this is an error. When I invoke SQR with x as argument, and x is not a constant expression, you see, this could not run at compile time. Therefore, I have an issue here. I get an error because SQR wants to run or can only run at compile time. Only in order not to to irritate you, we have usual functions. They only run at runtime. We have consteval function. They only run at compile time. And we have Constexpr function, which could run at runtime or compile time. It depends on the context in which you use them. And now, sorry, I come to constinit. Constinit guarantees that the variable is static with static storage duration is initialized at compile time. What does static storage duration means? You have a global, something which is defined outside any scope, or an object which is declared as static or external. And the key point is, now you have the guarantee that it is initialized at compile time. And here's the very interesting part. It's not constant. This is different to Constexpr. When you initialize something at compile time and you make it Constexpr, it's const. But with constinit, you only have half of the guarantee, which means initializing at compile time, but you can still change it. This is something which is extremely valuable in a concurrent environment. Okay, and this solves the static initialization order fiasco. I will not go through it. If you like it, follow this link. Okay. A few small improvements regarding templates. With C++20, you can use floating point values as template arguments, or you can use classes with Constexpr constructors. There's more. With C++20, you can, how should I say it? You can write template lambdas. These are lambdas which are parameterized on a type. I assume this looks strange, so let me show you something. Have a look here. Here are 3 lambdas. This is lambdas which we have since C++11. This lambda could only accept the int. Okay. This is generic lambdas which we have since C++14. And this lambdas could accept arbitrary values of arbitrary type, meaning first and seconds can have different types. And this is special, you see. Now I have a type parameter t, and first and seconds are of type t. What does it mean? essentially first has an arbitrary type, and second must have the same type such as first. You see, there's only one T here. And this is maybe an example which you may think is more meaningful. Have a look. Here I say I define a lambda which can only accept a vector. But what is variable here is the type of the vector. You see? You see it here. I have a vector and I can use this lambda. This is fine. But when I have a deck, which is of course not a vector, and I enable this line, we will get a compile time error. You see it here in a few seconds. Here you see it. No match to call for call 2. This is, by the way, GCC 11. See, you can define a lambda which accepts arbitrary vectors, but only vectors. Okay, let's go back. Okay, this was the end of the core language. Now I have to improvise because I cannot see the chat window. Let me see if I can see it. Are there any questions so far? Yeah, Victor, I see your point. Const is not const. Okay. Okay, sorry, but for me, is the Compile Explorer almost unreadable. Sorry for Martin for saying that, but first of all, I will send the presentation afterwards. You can have it. And second, I will try to increase the font size. Okay, let me go back to my presentation. You see, I have to switch a little bit between the screens. Okay, full screen mode. Now we come to the library. We have a few new data types, and the data types which may be extremely valuable for you is std span. I only talk about the span with a dynamic extent, not with a static extent. Okay, std span stands for an object that refers to a continuous sequence of objects. And here are the key points. A std span is never an owner. It references something. In this, what is referenced can be an array, a pointer with a length, or a std vector, of course, in C array. A typical implementation is a pointer to the first element and its length. You can also partially access the underlying or the referenced area. And here's the key point to take away. It knows its length. I could tell. Let me think. I will make the font a little bit bigger. I hope this would help. And also, let me make it here a little bit bigger. Okay. And here's the example. Have a look. I make this a little bit smaller because I don't care about the sampler code today. And let me draw this to the right. Okay. This is a function print me. It gets a std span with dynamic extent, and it displays its size, and it displays its elements. You see, I iterate through this container with a so-called range-based for loop. And a std span fixes this crucial issue we have in, how should I say it, in C or in legacy C++. And this is the following. You have a C array. You have a function who wants to have this C array. What does this function need? A pointer to the first element and its length. And when you have a bad day, you miscount the length of this array and you have an error of by one error, something like that. But this would not happen here. You see, you have here an array, a C array with 4 elements. And now the compiler deduces 4 elements, and here are the elements. I use here a vector with 5 elements. You see the same. And here in C++ array. And this is for me, I assume this is a main reason, or it's a main reason for classical C or C++ to get off by one error, because you have a C array and you only provide the caller the pointer to the first element. This is extremely error prone by design. Okay, this was stud span. Let me continue. There are many container improvements. And here's something which I'm totally, how should I say it? I was totally astonished. Stud string and stud vector got with C++20 Constexpr constructors. And the same holds for, how should I say, for the algorithm of the standard template library, such as find, if, sort, and you know this algorithms. And what does this mean? This means essentially you can create a compiler in vector and string at compile time. Sorry, I cannot show it to you because the only compiler so far supporting this feature is the Windows compiler, and I cannot execute on Compiler Explorer this example. But I have something for you. This time we have to study source code. I think we have the same issue. Let me go to 17, or let me go to 20, so it's big enough for you. And here's the interesting part. Once more, I use here the latest Microsoft compiler, and here's the point. I invoke this function max element, and I want to have the result, the max element of my vector at compile time. You see, I want to have it at compile time, and therefore this function has to be a Constexpr function. Consteval would also do the job in this case, but anyway. Now I have a vector with 4 elements. I sort this vector and I give back the last one, which is the biggest one. And you know what is the biggest element here? 46. Let me prove it to you. Here's the assembler code. You see, 46. It's all calculated at compile time. And this is for me a mind-blowing feature on the scheme. Okay. Let's go back because there are so many features. Okay, this is quite simple, so I make it short. You may know this irritating erase remove idiom when you want to erase something from a container, and this can be done in one step quite easily and quite intuitively using erase or erase if. And this could be applied to any container, and of course a string is also a container. So let me show it to you here once more. I have to make it bigger. I hope I will not forget it always. This time I'm curious about the result. And here, see, I have a vector. Sorry, I have a string. I displayed. And here I say erase if. Erase from my string all characters which are upper. And consequently, only this stuff is left. And once more, erase if is a free function, so it works on all containers. Okay. You know, I'm quite fast because there's much to explain. Here's something nice. What you should never do is use in one comparison signed and unsigned integers. I will show you why in a few seconds. And for that reason, we have safe versions of it. Compare equal, not equal, less, less equal, greater, greater equal. I assume you know what that means. Okay. Let me show you what I said before. Sorry, this was wrong. Let me go back. This was the wrong button. Here we are, not here. Oh, here we are. Let me show you what I mean. If you want to have a surprise, do it. You see, here I compare -3 with 7. And of course, you know that -3 is smaller than 7, but this is what the compiler is saying to me. Hey, this is not so good. Sorry, I have to adjust the output. No. Where is it? Where's my, sorry, you said, here we are. Okay, you see, -3 smaller than 7, false. Of course, this is false. What you want to have is true here. such as with should compare less. What is happening here? First of all, keep this rule in mind. Don't use signed and unsigned in comparisons, or also in any expression. What is happening here? CPP Insight gives me the answer. As before, I have to make it bigger. How can you make it bigger? Is this the one? Yeah, this is, now I made it bigger. And now let's have a look here. Let CPP Insight run, and now you see what's happening. This is happening. The signed X is converted to unsigned, and this is the reason why we will get this error. Okay, let's continue. Okay, we have arithmetic utilities such as new constants. You see, I make it short, so you have to look it up, or you can read my blog posts. And now I come to a big feature in C++20. You may know it that I have written a book about C++20, and in my second update, I looked quite detailed into this calendar time zones addition to the Chrono library. And you know what? It took me about 80 pages to describe this functionality. Therefore, I cannot explain it to you here. It's too much. I only give you an idea, and then I show you 4 examples, which gives you the first idea. We get new clocks. We get a new time point, which stands for the time of day. This is the day. This is the time since midnight. We get support for calendar dates and time zones. And once more, I will go into details. This would take me at least a day. So I show you a few examples. Have a look here. But I cannot show it to you live. Why not? Quite easy, because only Windows supports it, and therefore I have to show you my local Windows PC. I assume this is too small for you. So let me make it a little bit bigger. Okay, and I hope this works out for you. Okay, can I make it here a little bit bigger? Plus. No. This will not work. How can I make it here a little bit bigger? Plus. Yeah, here we are. Fine. Okay, I hope this is a quite easy program. First of all, I've defined time of day by just adding a few time durations, time durations, or literals for time durations, which we have since C++14. Okay. Then I display this value, and you see it here. To see it not, this is the wrong program. I should execute the one stuff I show. You see, time of day. And now I can get the hours, minutes, seconds, subseconds. You see, hours, minutes, seconds, subseconds. The duration since midnight, you see, 2 durations in seconds resolution. And I can also initialize time of day using exact this number I got here. You see, this number I got here, I use it here, and I get the same result. 40 minutes after 41 minutes after 12. Okay, first example. Second example. Now it becomes cute. Let me be cute. Voila. Please open. There's a cute syntax to define calendar dates. And here I used my birthday. And you can define calendar dates in 3 ways using a slash symbol. And the 3 ways are the ways, let me put it differently. You can start with the year, the day, and the month. And all the other 2 parts are therefore predefined or fixed. This is, let me execute it. Good. Here we are. You see, here are different ways to create a calendar day with staying for my birthday. And when I do something crazy, you see, the 26th month, I get the expected answer. It's not a valid date, of course, we know it. Okay. Now to the next example, local time. Once more, I can only give you a gut feeling. This is way too much. Let me execute this program. And here we have it. First, I have the local time here. This is by the way, this is a level feature. And now I displayed, you see it here. This is the line 12. And now I converted to 2 seconds, or I cut it to seconds. You see, I stop with seconds here. And now when I put this in a zoned time, you see, now I apply a time zone, which in this case is my time zone. I get the same time. You see, this is the current time in Germany in my time zone, and I can also do it I do it reduce it to the seconds. And here with get info offset, I got the offsets in Germany to UTC. And now I come to a quite sophisticated example. You may know that I'm a C++ trainer. Wrong example, I want to show you something different. No, this is the right example. I'm a C++ trainer. And you know with what issue I often have? I want to give a seminar worldwide, and which time zone should I use? You see, this is difficult. I give trainings for India, which are 6 hours ahead of us, or for Denver, which are, I think, 8 or 9 hours behind us. This is not an easy question to answer. Now I wrote a small program, and you see, I created a date, the 1st of February, and I want to give at the 1st of February a seminar which should take 4 hours. And I want to know which time it is in these different time zones, you see? And I want to start at 7 o'clock local time, 1 o'clock PM or 5 o'clock PM. And here's what I do. I invoke this function print start time with my calendar date, with the start time, with the duration of the class, and with the time zone. And here's the magic happening. Let me show you the output. It may be better for you to see both in parallel. I only show this the evaluation for 7 o'clock. Let me see if I can draw it to the left. Yeah, I can do it. And let me go back so you can see it. So first, I determined the start date and the end date based on my current zone, you see. And then I displayed. And this is a convenience function, get minutes, which essentially changes the resolution to minutes, because I don't care about seconds in this case. And now see, this is my start point. 1st February, 7 o'clock, end time, 1st February, 11 o'clock. And now this is only for layout reasons. I determined the lastest of this time zone strings. And here's the key point. What I do now is the following. I display the time zone here. Then I open this say list. And then I display the start date in this time zone. And you see, in Los Angeles, it's the last day of January at 10 o'clock PM. And this would end at 2 o'clock AM, which is maybe a little too early for a seminar. And here I do the same for all time zones. And here I do the same for all time zones. And this time I start at 1 o'clock. And here I start at 5 o'clock. Okay, you see, this is quite convenient. And this answers my question, which I often have. When should I start a seminar when I provide it worldwide. Okay, and now to the second big library in C++ 11. Sorry, 11, wrong, 20. C+20 is the formatting library. This is the alternative to the printf family. It requires the header format, and the syntax is based on the Python syntax, which makes it quite convenient for me because I'm quite good in Python. Okay, and you can specify all letters, text, alignment, signs, with precision, the data type, and so on and so on. I will show you a few examples. How does it work? Essentially, we have three formatting functions. Std format is the stuff I used most, but you can also say format 2 and format 2n, which means now it's written to an output array, and here at most n characters. And all the functions follow the same syntax. Let me check my time. Okay, it's fine. And this is the syntax. And why, once more, I use std format. You specify here in format string, here the arguments. And this is what you want to display. And all which is not inside curly braces is displayed as is. But here you can do something like apply argument IDs, you see. Here I say hello should be first, and then I would continue with world because I used the arguments in the wrong sequence. And you can specify here after this number using color and specify or use additional format specifier. I will not go this route because I will show you something. Okay. And the question is, for which data types can be displayed here? Of course, the built-in data types are fine, including std string. There's also addition. You can specify the data types of the Chrono library, which I showed you before, and which is so far not supported by any compiler. You can define your own parser and what is the other guy called? You will see it in a few seconds. For write your own data type in a formatted way. I will show you a simple example using a vector, but I have more sophisticated one in my book. Okay, let me show you. Here we are. I have to draw it to the left, format. First, the simple one. And this one I can display. Another one, execute. Another one, not. Format argument. Okay, you see? Here I say, let me draw it to the left. Here I say, just displayed. You see? So these are kind of placeholders, just displayed. Here I say, change the sequence or change the order. First hello, then world, and then 2020. And here I say, okay, I want to display hello 2 times for whatever reason. And here I skip world. Okay, this was easy. Now let me show you a way more, no, it's not so sophisticated. Let me show you a more sophisticated example. Where is it? Let me do it differently. Here we are. Okay. Now what I want to do is I want to display in vector. And vector of ints and a vector of strings. And what I have to do is to partially specialize formatter for vector. And you see here, I used a prototype library. In the future, this would be called std formatter, but now I have to use this library here, which provides the functionality, but because no compiler so far supports this. And what I did here, I wrote a parse and a format function, and the parse function essentially provides me the stuff I want to the format string. And this format string is essentially used here. And what I essentially do is, this is extremely simple, but maybe it looks a little bit weird. What I essentially do is the following. I apply formatting only to the members of the vector, in this case ints, in this case string. And here I do it in different versions. So let me show you the output. Honestly, I cannot show you the output. Why not? Because no compiler supports it. But remember, I have a vector of ints with the numbers 1 to 10. And here's the output of the program. Sorry, you see? Here I said use a plus sign before. Here I said layouted, use 3 characters to display this value. And here I say do it binary. And once more, you see, plus 3 characters binary. And now I do it a little bit different for format for a vector of strings. Here I say only the first 3 characters, you see, and therefore we see only here only for this. Okay. I have in my book an example in which I have a big vector, and I can even lay out it, make line breaks and stuff like that. So this is extremely convenient. But this example would be a little bit difficult for today, so only to give you a feeling. Okay, let me go back. I see that I'm quite okay. Wrong button. Here we are. Any questions? Naming const. The news about the format and it works to focus the format. Selling. Thanks for your remark. I will try it out with this new Visual 2022, but with my Visual it didn't work. It was not an issue so far because I can use the FMT library from Swear. I don't know his second name, sorry. Okay, thanks for your remark. I'm a little bit too slow or maybe too detailed, so let me go back. Now I come to concurrency. In concurrency we have a few very interesting features. So let me explain it, and I will make it a little bit shorter. First of all, we have, how should I say it, improved atomics. Stud atomic, which you know we have since C++11, stud atomic flag, which we also have since C++11, support this 3 new member functions: notify one, notify all, and wait. This means you can wait on atomic. And this waits exactly when the value of atom is equal to 1. I forgot to say something. We can also have atomics for floating point value, which is also a new 20 feature. Once more, you can wait on atomics or atomic flag. And they are the default constructor initialize their values. And let me show you an example. And I'm happy to say now I can show you something which I could use Windows, but also I use Clang here. But anyway, does not make a difference. Here's a simple workflow. Have a look here. I have a thread which is waiting for work, and I have a thread which notifies this other thread. And keep this workflow in mind because I will use it once more in a few seconds using a semaphore. And let's see. I initialize this atomic bool with false. This means this call here waits. Why? Because this atomic bool has the value false, and I wait when I'm false. How long does this thread wait? Exactly so long when this happens. You see, this is the set data ready flag. This thread prepares the data. Put some value inside the vector, says data prepared. Okay, you see it. And then it stores true inside the atomic. You see, from false it becomes true. And then it sends a notification. And this is the point where this guy can continue. Puts his 2 inside this vector, and then the vector is has all values. Okay. You may know that you can also use for this kind of workflow condition variables or a future promise pair. I don't say anything about future promise pairs, they would be also fine here, but don't use condition variables. First of all, they are extremely error prone. Second, they are slower. Okay. Maybe you know it, I assume you know it. We have a stud shared pointer, stud weak putter since C++11, and the question is which multi-threading semantic they support. And the question is quite easy. A stud shared put or stud weak pointer only guarantees that the control block, so the handling of the smart pointer of the reference counter, is a thread safe operation. But there's no guarantee regarding the resource the shared pointer owns. This ends with C++20. Now we have partial specialization of stud atomic for shared putter and weak putter. And this means you can apply atomic operations, you must apply atomic operations on them. And therefore, there is not only the control block, but also the resource, by definition, thread safe. Okay, you see, I'm quite fast. Okay, good in time. We have semaphores in C++20. Semaphores are simple synchronization mechanism. What's the idea of a semaphore? You initialize a semaphore with a value typically bigger than 0. When you request this semaphore, this value is decreased by 1. When the counter becomes 1, the semaphore requesting this requesting semaphore is blocked. Okay, once more. In counter bigger than 0, typically. Each one requesting this semaphore decrease the counter by 1. When the counter becomes 0, this requesting thread using the semaphore is blocked. Until someone releases the semaphore and the semaphore counter becomes 1, goes from 0 to 1. We have two types. We have a counting semaphore and a special counting semaphore, which has a counter of 1. Meaning it can only have values from 1 to 0. Okay, now I said to you, think about this, remember this workflow. Let me go back. This is exactly the same workflow I showed you before, but this time, no, sorry, this is not so easy here. This time I use a semaphore. You see, waiting for work, set data ready. And here I do it differently. I use a counting semaphore initialized with 1. Now let me put it differently. It can at most have the value 1, but initialized with 0. What does it mean? This call here is blocking because the current counter is 0. It blocks until this call here happens. Prepare signal release. This releases or increment, this notifies this guy here, acquired, and also increases the counter by 1, which means now the counter is 1. Therefore, this guy could continue and make its work. Okay, this was a semaphore, and only to give you an idea, semaphores are extremely fast synchronization mechanism. I'm not sure if this always holds, but on my PC, a semaphore is faster than an atomic. Only atomic flag is a little bit faster when you want to synchronize something. Okay, you see, semaphores are quite easy to use and they are quite fast. So why you should use them. Okay, now I come to something which I make a little bit shorter. I come to latches and barriers. Latches and barriers are also synchronization or coordination mechanism, but the idea is different. You set a counter to a specific number, and each thread can decrease the counter by default by 1, and a thread waiting on a latch or barrier has to wait until this counter becomes 0. And there are different ways. Here, this means only count down the counter by 1. This means wait when the counter is bigger than 0. So the other way around compared to semaphore, it blocks when the counter is bigger than 0. And this says I arrive, decrement the counter, and I wait. You see, this is a combination of count down and wait. And you can specify here different value for the counter update. Okay, and there's one specific part which is there's one difference between latch and barriers, and this is the following. a latch can only be used once. So once you want to synchronize a few threads and they can continue here when the counter becomes 0. I will show you an example in a few seconds. But when you want to do a job more than once, this is the job of a barrier. A barrier has a simple interface, but a little bit different. The difference is once more you can increment, you can use a barrier more than once. So you have a job which repeats a few times. And there's also this interesting call, arrive and drop. This means you decrement the counter, and in the next iteration you say, I don't want to play your game anymore, I'm out of it. And there's an additional functionality which a latch has. When you initialize, which a barrier has, when you initialize a barrier, you can give it a so-called executable or callable, which is a function which can execute it. And this function will be performed when the counter becomes 0. This is the so-called completion phase, and one of the threads will perform this function. And what I don't know what you want to do. Maybe you want to publish something because this work is done or something like that. Let me show you a simple example, but only using let me see, a latch, because I only synchronize once. First of all, let me increase the font size, and this is not so good. And let me increase the font size of the result. Here we are. What do I have? A small job. You see, I have a few workers. Herb, Scott, Bjarne, Andre, Andrew, and David. You see, 6 workers, and they have to perform this work here. This is a function object, and this is what they have to perform. And the key point here is the following. They say arrive and wait. This means each time this call is made, the count is decreased by 1, and they wait until the counter becomes 0. And you see what? I initialize the counter with 6. I have 6 workers. So for they wait until each worker is here and decremented the counter. And therefore you see here, first all threads say work done. They wait here, and then they can go home. And interesting. This is more interleaved than this, but anyway. Here I use, by the way, a feature of C++20, which is synchronized output stream. This .osync guarantees that this line is written in atomic fashion, essentially. Without this, only using std out here, this output operation could interleave, which I will not do because it looks ugly. But it's not a database. Okay, 5 minutes are left. Let me continue. Okay, this I make a little bit shorter. I'm totally happy. I'm just in time. Okay, what we can do with C++20 is cooperative interruption. This means all what can run in C++, a future, promise, a thread, you know, a package class, all what can run can be interrupted. And 2 data types have an extended interface in C++20. This is a G thread, and of course this is a C++20 data type and a condition variable any. But first let me explain it to you without going to the details. I only want to give you an idea. This cooperative interruption exists of 3 parts. Essentially, we have a stop token, which can ask if a stop was requested. We have a stop source, which can signal a stop request. And we have a stop state, which both of them share. Okay, let me skip the theory. Let me show you an example. And here's the example. Okay, here we are. Here's the example. This was the wrong button. Once more, here's the example. Okay, first of all, a little bit bigger. Second, also here bigger. And you see, it's red because I wrote to std error. So the error channel. Okay, see what I have here. I have a main program. I use 2 threads executing this function non-interruptible, or I call this thread non-interruptible, executing a lambda, and this called interruptible, executing a lambda, and here's a key difference. This lambda gets a stop token. And therefore, I can use this stop token to ask, hey, did someone wanted that I stop to execute? And if so, I return. Once more, this is cooperative interruption. This thread has to decide, does this thread wants to interrupt? And you can only send this signal once. And here's the main thread. It sleeps for 1 second, and then it requests both threads to stop. But only the interruptible thread can be interrupted or gets the signal, because this thread shares only, they only have a shared state. And now you see here, non-interruptible 5 times, exactly 4 times. Now the main thread says request stop, only this thread reacts, therefore only the non-interruptible continues until this thread is done. Okay, this was cooperative interruption, and once more, this is not only to a G thread, you can use it with anything which runs. Of course, a classical thread would also do its job, the job. Okay, and when you look carefully, I used here G thread. By the way, this J stands for joinable, because G thread is an extended thread from C++11, and this is the last thing I want to say. And a G thread automatically joins in its destructor. When you would use here a thread, wait a second, then when this thread T goes out of scope, in the destructor of T, std terminal would be called, which will call typically resides in the std abort. Okay, this was it. Once more, extremely fast. I talked about C++ 20 without the big 4, and you see there's a lot of stuff inside. I make this short, so let me give you an additional point. Maybe you want to read the details. I have 2 ideas. First of all, you can read my blogs. I assume I have written about 80 posts about C++ 20, and you see, about 80, and I will continue to write a few because I'm always learning something new. So you can read this stuff here, or you can do it another way. Of course, you can buy my book, and I updated it the second time. No, I only updated it once, and then you can read it in about 60, 100, 550 pages or something like that. And until Sunday, I have you can have it for 50% off. Now the question is, how can you use this coupon? Quite easy. I will publish my presentation in a few minutes on Twitter and on my Facebook group, and then you can have it. And if this works not out for you, just write me an email. Okay, this was it. Let me go back to the chat window. And let me see if I have if there's a question. Is latch only a facade for semaphore atomics? Honestly, I don't know it, but I don't think so. How would I implement it? I would use an atomic int and then would make a kind of a safe synchronization. I would build abstraction around an atomic int. And with C++ 11, 20, we can notify using atomics. Now, I assume this could be done. And there you need additional kind of notification mechanism. But this is, of course, also in the atomic. I would assume this is maybe based on an atomic int or maybe also an atomic latch, but I don't know it. Sorry, Thomas. You have to study the Windows sources on, for example, GitHub. Okay, now I'm done. If there is not any question left, I will go into the rooms and sit onto a table, and you could see me or talk to me.
Okay, thank you, Rainer, for your presentation. And yeah, we will meet in the launch, maybe.
Okay. Thanks.